Hello, this is FlippedHarber for Algebra 2. In this video we're going to cover section 6-7, investigating graphs of polynomial functions. Our objectives for this lesson are to use properties of end behavior to analyze, describe, and graph polynomial functions, and to identify and use maxima and minima of polynomial functions to solve problems. The outline for this video will talk about graphs of polynomial functions. We'll talk about end behavior and how to determine end behavior. We'll talk about some steps for graphing a polynomial function, and then we'll take a look at turning points and local maxima and minima. Now really what I want to do is go through what each graph of a polynomial should look like. We'll start with the most basic polynomial, and that's a linear function. You should know how to graph this using the y-intercept and the slope. Shouldn't be a big deal at all. So this would be an equation for the line for a polynomial in the form mx plus b. Now a quadratic function, that is ax squared plus bx plus c, we've talked about a lot, and you probably really shouldn't have any problems graphing this either. You can find the x and y intercepts, you can find the axis of symmetry and the vertex, and you should be very used to this. As we get into the higher powers, such as the cubic, you're probably going to have to work a little bit harder to graph these. When in doubt, just make a table of values. Now you'll notice that the cubic function shown here starts in the lower left part of the graph, goes up, turns around, goes back down. We say that the graph is decreasing there, and then it turns around again and continues up and to the right forever. So all cubic functions have this shape where they point down in one direction and up in another. A quartic graph, that is a polynomial with a degree of 4, looks a bit like a quadratic in the fact that both legs or both sides of the graph point up or both point down. You'll notice that this graph turns around several times. Here's a quintic graph, that is a polynomial with the power of 5. A lot of turning points in this graph. We'll talk about what turning points are later, but it's probably pretty obvious that this is a turning point where the graph turns from decreasing, that is going down, to increasing. So you'll notice something about these graphs. As the power gets higher and higher, these graphs can get more and more complicated, but they have things in common with each other. Let's talk about end behavior. End behavior can be described based on the leading coefficient of the polynomial and the degree of the polynomial. So here you see our graph for our quadratic polynomial again and our cubic polynomial again. You'll notice that with the quadratic, which is true for all even powers, both sides of the graph, both end behaviors, both point up in this one. If this were a negative quadratic, that is if the leading coefficient was negative, both of those legs would point down. So all even polynomials, both end behaviors point either up or down. This cubic is a good example of an odd polynomial, that is the highest power is an odd number, 3, 5, 7, so on. One leg points down, one side points down, and one side points up. Now this is a positive cubic, meaning that the coefficient is a positive number. If our leading coefficient was a negative number, this graph would be flipped and it would be pointing up and to the left and down and to the right. So when we talk about end behavior, we talk about which way it's pointing to the left and which way it's pointing to the right. Graphs either point up or point down. Now let's talk about some steps for graphing a polynomial. Sometimes it's nice to find the zeros, and we've spent some time figuring out how to factor and find the zeros for polynomials. So finding the zeros is another way of saying finding the x-coordinates, the x-intercepts. And finding the y-intercept of a polynomial in standard form is really easy. It's that constant number at the end. If there's no constant number at the end, your y-intercept is 0. So find the zeros and the y-intercept of the function and plot them. Determine the end behavior. Does it point down or does it point up? Make a table for several very easy x values. Don't choose numbers that are oddball. Don't choose 2.64. Choose 2 or 3. plot the points, and then just draw the graph. Now let's talk about turning points. Here's our quintic polynomial again. These turning points are where the graph goes from increasing, we said that the graph is increasing right here, to decreasing. So it's a turning point just because literally the graph turns around and starts going the other way. So here's a turning point, here's a turning point, here's another turning point where it goes from increasing to decreasing again, and then finally here's our last turning point where it goes from decreasing to increasing. Another name for these turning points for polynomials are local maxima and minima. This is referred to as a local maximum because it's the point that's higher than the points next to it. This would be referred to as a local minimum, another local maximum, and then another local minimum. So our turning points are actually also our local maximum and minimums. The only difference is when you talk about turning points, you're talking about x, y coordinates. This is a turning point. You have to give the x value and the y value. When you talk about it as a maxima or minimum, then you want to just give the y value for this point. So when they talk about maximums or minimums, give the y coordinate of the point. Okay, so that's it. Obviously we're going to have some graphing in this homework, so make sure that you do that on graph paper. I'll see you in class and I'll see you online.